Hello everyone, I'm Mariam from University of Florida, and I have to say that I'm so glad that I've got the opportunity to present my study in front of professionals. Thank you so much for listening.
Hello everybody, hope you're doing well and staying safe. My name is Maya. I'm a PhD student in construction management at the University of Florida.
The research proposed by our team will result in the design of a home that is hyper-efficient and energy self-sufficient, and that is able to cope with future severe weather events while also providing basic services needed for families during post-disaster recovery. We refer to this research as Advanced Modular Housing Design, AMHD. The AMHD research will address the design of housing that can be rapidly built in factories, that can cope with the future major events, and that can become a major community asset. The natural disaster that we will consider in guiding the identification of technologies required for the AMHD include hurricane force winds, flooding, and storm surge. The attributes required for AMHD post-disaster housing include high structural strength, high level of energy efficiency, energy self-sufficiency, and deconstructibility. We will consider novel, high-strength materials that are compatible with and enhance rapid modular housing manufacturing. We envision housing that has built-in renewable energy systems and energy and storage to enhance post-disaster living conditions. Future post-disaster housing must be designed to contribute to community resilience and serve as the foundation for the construction of the community. In summary, the solution we propose for addressing the problem of how to rapidly provide large quantities of post-disaster housing in advanced technologies and process improvement that support the design and manufacturing of resilient, sustainable, and affordable post-disaster housing. The housing must be rapidly manufactured in significant quantities, transported to a suitable location, and rapidly erected. This proposed research project will address the enormous challenge of rapidly rebuilding communities that have been badly damaged and perhaps even destroyed by major storms. This problem will likely become even more challenging due to the increasingly powerful and more frequent hurricanes that are forecast to strike the US, and particularly coastal regions. The result of these events have been and will continue to be severely impact communities whose housing stock is essentially destroyed, leaving their population without adequate shelter, often for long periods of time. To address the problem of rapidly delivering large quantities of post-disaster housing in this proposal, we will focus on how the modular home manufacturing industry can help provide solutions.
This research will be conducted in the context of three key challenges facing the U.S. housing industry: resilience, sustainability, and affordability. With respect to the problem of resilience, this research will consider the technologies that can make housing survivable and contribute to long-term community resilience. The scope of the principal climate change-related threats facing housing in the U.S. that will be considered in the research includes high winds, flooding, and ocean storm surges. Sustainable housing can both address climate change and be more resilient than its conventional counterparts. Passively designed and low-energy housing equipped with renewable energy generation and storage technologies can greatly reduce energy costs, lower carbon emissions, and help make housing energy and water self-sufficient during power outages caused by disasters. Housing affordability is being challenged by numerous factors: looming severe shortage of both skilled craftspeople and construction labor are threatening the viability of the industry and contributing to the accelerating inflation of construction costs. We consist of three themes related to three dimensions of the project. The project designed for 2 years of research and design. Over these 2 years, three charrettes were set up to gather all ideas together and come up with the best solution out each step. Charrette 1 was about the strategies. Charrette 2 was related to users' demands. Charrette 3 will be related to factors and producers. And the final report will result to an architectural BIM model, energy simulation, life cycle assessment, cost estimation, and proposed factory solution. Thank you very much for listening us and have a great day.